Hey everyone, so today we're looking at a number called Euler's number, and usually we just refer to it as E. So in order to show you where this comes from, first we need to consider the form 1 plus 1 over n to the nth power. If you're wondering what this is a form of compound interest calculation, and this is basically a shell of the compound interest formula. So this is talking about an investment or maybe how much debt grows, and n is usually referred to as the number of times your investment or your debt is compounded. So for example, if I have something that compounds 10 times, I might write it in a way 1 plus 1 over 10 times to the 10th power. And if you plug all that into your calculator, eventually you get 2.5937 as an answer. Now, if I raised it to a slightly bigger number, maybe a lot bigger of a number, like 100, what I notice is that my number jumps up to 2.7048. And then if we do this again and we raise it to another power, let's say 1,000 this time, my answer comes out to 2.7169. So you can see this number is growing a lot faster from here to here than it is from here to here. Well, let's look at one more example. Let's look at 1 plus 1 over 10,000 to the 10,000th power. Okay, so this would be an investment compounding 10,000 times a year. But it'd be 2.71814 as its value. And so again, you see the rate of increase has decreased a little bit. Pretty much if I was to visualize what's going on here, if I plotted this as a function, if I went over to where 10 was on the x-axis, it would output about a number, if this is 2 and this is 3, it would give me about a little over 2.5, which would be about right here. And then if I went over to 100, let's say 100 is right here, it would give me about 2.7, which maybe let's say is about right here. And then if you did the same thing with 1,000 and with 10,000, my plots would, start to look something like this. And so what we realize is when I plot all these numbers, this actually turns into a type of exponential decay function. If I plugged in 1,000,000 for the number n, what I realize is it's ultimately getting closer and closer and closer to some number. And what that number is ultimately the number 2.71828. You can approximate this by taking the limit of this function up here as n approaches infinity, which you can do in calculus later. But right now, this number is a number that is very special, and this goes on forever. It's an irrational number. And what we call this number is E. It's very similar to pi. Pi is a certain number, 3.1415, and so on. And we just call it pi because instead of writing all this out, it's easier to just call it pi. Well, E is the same way. The number E is basically a constant that represents when I continuously compound something. So the more and more I compound in my compound interest function, the closer and closer I get to this constant E. And this E is a very important number. One of the reasons why it's so important is because of its continuous compounding. And for example, we use this constant in the formula for continuously compounding interest. This constant is also used in what we call Newton's law of cooling, which is a really fun law to play with, which we will play with as we get more into logarithms. So if you're somebody who's interested in biology, where you're looking at population growth, or if you're looking at how fast germs spread, maybe you're interested in finance, where you're looking at how fast investments compound or how fast debt compounds, this may be a number that you find yourself using quite a bit in the real world.